Good morning, everybody.
Hi, good morning.
Good morning.
Good morning.
Good morning.
Uh, I feel it's good time to start. So let me share my agenda screen. It's there on the shared content. Confirm if it is visible.
Yes,
Okay. So in today's session, we are going to start with the unit testing, what exactly it is, where it is required, why it is required, its benefits, comparison of different unit testing tools or frameworks which are available, along with the different types of testing that exist, like integration testing, acceptance testing, etc. When it comes to frameworks, we'll be having a comparison between NUnit, XUnit, MS Test, the three most popular frameworks which are being used, out of which our focus will be mainly on XUnit, because this is the most modern framework which people are using these days. Then we'll move on to the practical implementation, where we'll see how to set up a simple C# project for unit testing, how to write a simple unit test to verify the functionality that we might be coding. Then we'll move on to discuss about the test-driven development approach, what exactly it is, why we should follow this, and how it benefits us. And then there is a popular mechanism or methodology which is used while going with TDD, something what we call as a red-green refactor cycle. What it is, where does it stand into the test-driven development? We'll discuss about it, and then we'll also be talking about the best practices for writing the effective unit test cases, and then something specific to the tools like how to, what are test fixtures, how to use them to organize the test, how to write something called as test suites to group the related tests together, and then the role of the test runners and how do we use them to execute the tests. Okay, so let's start with the very first part, overview of unit testing and its benefits. Now, here the first thing that we should be focusing on is unit. If we are talking about unit testing, testing is something that we can understand easily. This is more about testing what code we are building. Now, what is unit in this case? Anybody?
Functionality or method.
Yeah. So at the lowest level, it could be functionality, a method, depending on which software development paradigm you are using. We might say function, method, or different other terminology is there. At times, it may not be just one function or one method. It may be a chain of methods also that we might be testing, right? Where we have the cascading calls from one method to another, to another, to another, and so on. Correct? So the unit precisely can be as atomic as a function or method, or it can be as concrete, as complete as a complete module also at times. A module which then belongs to some other application. So one section is the most generic term that we can say is something that can be termed as unit. Now this section, as I said, can be a method. This section can be a group of methods. This section can be a class. This section can be a complete component. Not module, I will say. It could be a component, right? Now, whatever the code that you write, don't you think it is important to see whether it is doing what it is intended to do before we actually integrate this implementation with the main application by including it in the build cycle. Is it important or not? It is. Now, who is responsible for writing the unit tests and ensuring that these unit tests run and provide the positive result for all the input that goes in? Is it the QA team which does this, or is it the responsibility of the development team?
It's
Responsibility of the
development.
development team.
Development team, for which the guidance might come from QA or the architect team also, where they may put their expectations already that this is the kind of input that should go in, and this is what the expected result is. For all positive and negative tests, they provide the input. It could be available in the form of a simple Excel sheet also at times, which the development team that needs to transform into some runnable or executable code, which basically is what we call as test case, right? So if I say, what is the definition of unit testing? How do you define it? It is a fundamental software testing technique that is used in software development cycle to verify the correctness of the individual units or the components of your application. And as I said, the unit is usually the smallest testable part of your application. Means it can be a function, it can be a class, it can be a complete component as well, which consists of multiple classes, where multiple classes consist of multiple methods, right? In itself, the component is not a complete software. And why the development team is responsible for writing these? Two reasons. One, the unit test cases are built using a lot of code, and developers are the best people who understand the code and who can code easily. The second reason is they know what kind of code they have written, and to use that code for testing purposes, what code further is required, right? Now, I might write the test case, which probably gives me positive results in all the cases for my own functionality. I can tweak the test case like that. Without writing any test code, I might say that, okay, just return the positive. Different developer to write a test case for other team member, right? So that it will be totally independent, right? So ultimately what unit testing involves, it involves writing and running the tests for the different individual units in complete isolation to ensure they behave as expected. Correct? I hope this is clear. What unit testing is, what it does, what is the purpose of it. Anybody having any questions? Okay, so let's move on to the next part where let's throw some light on the key components of unit testing. The first is something what we call as test cases. What are test cases? Precisely, test cases. Yeah, go ahead.
Means if we are testing some functionality,
Yes.
we write these some steps means to execute that functionality, kind of to call the method, and if there is another call to this service, then mocking that service. So we include it step by step within the function. That is the test case.
Yeah, functionally, what you said is exactly the same thing. But technically, when we go with the definition, it's not like that. Test cases involves all the inputs which goes in to your unit. Maybe I can term it as input one, input two. This is something that represents all of your parameters. So I'll just put it as input. Then for the given input, what is the expected result? This combination is what we call as test case. When I give this as input, this is what I expect. When incorrect input is there, I expect exception. So I'm giving different types of inputs, and then I'm providing the expectations. Whenever this input goes in, what should be returned back to me? This is something what we call as test case. And that's why I said these test cases might be actually provided by your architect team, or to make it more quality oriented, it this test cases might come from the QA team also. They might analyze the entire software, its requirements, and then prepare their own test cases, right? So definition wise, what we'll call this, test cases are specific inputs and the expected outcomes or results designed to test a unit of code. These test cases should cover various scenarios, including the positive and negative inputs. In other words, we call it as normal and edge cases. I should be going with extremes of the inputs as well. What would happen if I go for the extreme inputs? Gracefully, I must be reported with an exception so that I can say my code is fail proof. Understand? Understand? So your test cases can be written on the piece of paper, can be written as Excel sheet, which then needs to be transformed into some testing code later on. Got it?
Yes.
The second key component is what we call as test framework. This is easy. We know what is framework. So we just need to understand what it is with respect to testing. To actually transform the test cases to some runnable piece of code which can execute our test cases, we need some sort of tools, right? The code that we write here is something what we call as tests, not test cases actually, right? For which we need this test framework. So this can be a framework, it can be a simple library. Whether it is framework or library, its job is to provide some tools for writing, organizing, and running your tests. Examples, any test framework that you know, there is something called as JUnit. There is something called as N unit. There is something called as MS test. There is something called as X unit. There is something called as pi test, right? And this list is very big. JUnit is the unit testing framework built for Java based code. NUnit is .NET version of JUnit. So it is the same framework, but built for writing the test for .NET code. MS Test is default unit testing framework available with Visual Studio for any .NET application. Then XUnit is built on the concepts of JUnit and unit only, but taking it to the next level by giving more clarity to whatever the test you are writing, by simplifying the way how we write the test cases and the different tests using the JUnit and unit. So it's a different framework altogether, more refined, more optimized. PyTest is the unit testing framework for Python code. Understand? Without the existence of these test frameworks or libraries, we can't do any testing. Usually the unit testing is a automated testing, right? Is it clear?
Yes.
Next is something what we call as test runner. What is this? By the name itself, it should be clear that it is a tool that is responsible for executing the tests, preparing the reports about success and failure. This test runner can be integrated with your IDE like Visual Studio or Eclipse and other IDEs, or it can be a command line tool also. At times, it can be a browser integrated tool as well for web applications. Understood? Again, which test runner you use depends on which test framework you have selected. If your test framework selected is XUnit, your test runner will be provided by XUnit library only. Is it clear?
Yes.
Now let's talk about some of the benefits of unit testing. Okay. First benefit, very important one, early detection of bugs. Is it important one or not?
Yes.
Why?
For example, my I am sharing my experience. I was working for one of the tax calculation unit test cases. So there was a
Yes,
mistake in the software. So when I
yes,
calculate by the test cases, the text was getting wrong. So in real
yes,
scenario, if someone is calculating text and it goes wrong, it's affect to
yes,
its credibility to the government. So it's
correct.
create a problem. So to avoid that kind of real life problem, if we early detect the issue, it's beneficial.
Yeah, so just a bit of correction in that. Like when I'm in the development process, before I integrate my code, my components with the main application, if I detect the issue, I detect the bug in my code, it will be possible for me to troubleshoot it, debug it, and correct it even at even before it goes live, right?
Yes.
Instead of failing late, I try to fail early, right?
Yes.
Which saves time, which saves efforts, because after integration is done, finding out where the issue is very difficult and time consuming process. But
Mm-hmm.
when I'm working on the specific unit, and that is where I am getting the failed results, I need to focus only on that isolated portion of the implementation, right?
Yes.
Amount of code will be less. The unit will be a smaller unit, which will take less time and will be easy to debug and troubleshoot, right?
Yes.
Okay. This is the benefit that we get with early detection. Understand?
Yes.
Agile model also basically talks about this only. Fail early than late. Correct?
Yep.
Next is better code quality or improved code quality. Of course, that's the motive, right? Probably I need not explain this. The more, the better test cases you have created and the test code you have written, it will allow you to write more cleaner and more modular code, which leads to better code organization and maintainability. Hence, at the end, you get improved or better code quality. Yes or no?
Yes.
Now, for this to be working at the top level, you should actually write your test first of all before your code actually is developed. So that whenever the code is developed, the tests are ready to see if the functionality is being done or being implemented in the right way. Yes or no?
Yes.
I mean, the standards are already set, correct?
Yep.
Third is documentation. Documenting your code is important step, right? Just writing code is not enough. Reason, you will not be working on the same code for lifelong. Even if you do, someone has to take it over later on, right? Because we are not like immortal, correct? If we think practically, someone has to take over your work at some time. So how the next person taking over understands your code? That's why documentation is important. Your unit tests also serve as documentation for how the specific unit of code is supposed to work. The person taking over the maintenance of that code from some other person can refer to the test to understand the overall intended behavior of this code. Yes or no? Definitely, as a part of the documentation, the comments, the XML comments will also help. But the overall behavior, if someone wants to understand, I mean, what input gives what kind of output, that makes someone understand the overall implementation more easily, more practically. Yes or no?
Yes.
Next is regression testing. So here, first of all, we need to understand what is regression. Can someone tell me?
When we develop modules, it's stable now, but because of in futures next sprint or future sprint we do some modification, so
Yeah,
existing functionality should not break and new functionality should
correct,
work. So
correct.
existing code base if negatively impact, we should do troubleshoot and find out. That's called regression to
Yeah,
parallelly
so
test
that
our modules.
this is something what we call as regression testing. Regression in itself means maintaining or reverting back to the original state, right? Maintaining or reverting back to the
Yes,
original state of the object. So ultimately, here this object is code. So whenever you are modifying the code for maybe accommodating the change requests, or if some bug is being reported, right? You're changing the code. Changing the code should not break the existing functionality and just keep on working as expected. For this, you need to keep on rerunning your unit tests again and again whenever there is a change. Even if that change is 0.01%, you have to run the test case every time. So whenever the code is modified, you should have some mechanism which lets you know that this code has been modified and the test needs to run on this. This ultimately helps in preventing the introduction of new bugs while modifying the code. Understand?
yes,
Next is facilitates refactoring. What is refactoring, by the way? Refactoring is the process where we change our code maybe to adopt a different methodology to get the work done. Intention of which might be to improvise the code quality, to optimize the code, to optimize the resource utilization, etc. The inputs might be same, the outputs might be the same, right? But
yes,
more effective code we might want to bring in. You know, in simple mathematics also, there are hundreds of ways to solve a particular problem. Same way within softwares also, there are hundreds of ways to get something done. Initially, we might end up with something that we are good at or that we know, but at some later stage, we might realize that this is not the most optimized way. Say, for example, if I talk about sorting, there are 8 to 10 sorting methods available, right? I might write up some method which I am good at. But at some later point in time, I realized that this is not the best sorting method available for the kind of data I am working with. So I might want the the sorting algorithm to be changed to the most optimized algorithm, which might be more suitable for that data type. Correct? This is where I'll go with refactoring. Sometimes this refactoring also depends on, like I've written some code in one method, but at some later stage in the development process, I realized that there is some redundant code being implemented. So I want to further modularize it. I break that functionality into multiple different methods or even different components if required. If I feel that will be the best, because some of the code might be reused in some other modules, other components as well. That also comes under refactoring. Now, with unit testing in place, the developers can refactor the code with confidence, knowing that if they break anything, if the refactoring process breaks anything, The unit tests are there to catch this break and prepare the negative report. This will assist in promoting the code improvement without the fear of introducing defects. Got my point?
Yes.
Next is isolation of issues. Isolation means some sort of quarantine. I run each unit test into an isolation for a specific unit of code. Now, that itself says that if there is some issue with the specific unit of code, it will be limiting the unit test to that specific unit only. So that unit will be declared as failed. When I modify the code, troubleshoot the code, I just need to probably rerun the unit test for that piece of unit or that unit. I need not run all the tests all the time. So this will help me save a lot of time and increase my productivity. This also is important because when a test fails, it actually becomes easy to pinpoint the problematic area, making the debugging more efficient and more targeted. Yes or no? You clearly
Yes.
get the report that this is the unit, and in this unit, this is the method which failed. So your troubleshooting concentrates only on that, right?
Yes.
Like during Corona days, if one of the family member catches the infection, is used to be quarantined, right? And for the safety reasons, the tests were being conducted for other family members also. Now, if it is detected that the first person having some symptoms is the only infected person, the medical team used to concentrate for the treatment only on that person, with precautions being advised to the other members. The other members, being in isolation, never used to come in contact with the infected person, preventing themselves from catching the infection. Yes,
Yes.
and this was very important before the introduction of the vaccines, correct? Because there was no treatment, correct?
Yep.
Then next is unit testing supports CI, which stands for continuous integration. So it can be the part of the CI/CD pipeline. CI, continuous integration, what it does, it picks up your checked in code, compiles it, integrates with your rest of the application, and then prepares a release with the help of CD, continuous delivery, right? Now, in that process, we can make the unit test as mandatory part. So whenever some developer in the team checks in the code, first of all, the test must run and the test must result positive for all the implementation that is being checked in. Then and only then it goes into the CI pipeline. Otherwise, CI doesn't pick it up. That will improvise the code quality automatically. So if anything is changed, first the tests are automatically executed, even if the developer has forgotten to run the test case, which will ensure that the new code does not introduce the regressions, right? Is it clear?
Yes.
Then one thing that we are continuously talking about comes next, increased productivity. Precisely, I can say increased developer productivity. Because developer knows that whatever code I'm writing has to pass the tests. So as a developer, probably I already take care of the code that I'm writing so that it never fails. I just take care of all the conditions, right? I do proper uh, input testing. I mean, input handling, where I check the parameters, I validate the parameters, I validate the data at all levels so that the code never fails, never breaks. I throw the exceptions if I find anything wrong with respect to the input, right?
Yes.
Otherwise, my code I know will not be accepted in the CI pipeline. Correct?
Yes.
Next is confidence in code changes. Partially, we have already discussed this. Developers can bring in the changes with confidence that nothing will break. This is already being taken care of by regression testing, right? So that makes the code to be easier to be maintained and allows your software to be evolved over the time easily, right? Next is better collaboration with the team members. Because the unit tests provide a common language and common understanding among all the team members. They simply help the developers to communicate the expectations and requirements of the code behavior, right? To summarize this part of our discussion, I'll say the unit testing is a crucial practice in the software development process that offers the numerous benefits like early bug detection, improve code quality, increase developer productivity, and plays a very, very important or vital role in ensuring the reliability and the maintainability of your softwares. Got it?
Yes.
Any questions here?
No.
Okay. Now let's talk about the next section, the different types of testing which are important in the software development process. So types of testing, one we just discussed, where the first one is unit testing, something taken care of by the developer team only. Next is integration testing, which is done by the QA team most of the time. Third is acceptance testing, which is done by the end users, UAT, user acceptance test, right? Now these all testing may have sub branches. Like integration testing might involve performance testing, load testing also. Correct?
Yes.
Top level categories, if I talk about, are these only. Yes.
Yep.
Let's compare all of them. First point of comparison will be what we call as scope, right? What is the scope of unit testing? What it focuses on? As we discussed, unit testing focuses on testing the individual components or the units of code in isolation, which may be functions, methods, classes, or the complete component as well, right?
Yes.
What is the scope of integration testing? Integration testing focuses on testing the interactions and the interfaces between the different components or the units within the application, rather than focusing only on individual units. So basically, when we integrate different units together to form a software, that's where integration testing focuses, whether they are interacting with each other the way they are expected or not. Got it?
Yes.
Yes.
What is the scope of acceptance testing or UAT? This acceptance
So
testing is the highest level of testing that focuses on validating that the entire software system meets the specified requirements and satisfies the business objectives. That's why it is usually taken care of by or done by the group of end users, right?
yes.
Next point that we can use for the comparison is purpose or the need. So unit testing purpose is to verify the smallest parts of the or units of the software work correctly at the lowest level or granular level. Unit testing checks whether the specific unit behaves as expected for given inputs. So that's where inputs and expected outputs are important. Correct?
Yes.
If I talk about the purpose of integration testing, then
If you want to check kind of flow, like for example, after login, I'm doing some action, and the based on action,
yes,
there will be next action. So sequence of actions we want to validate.
correct. And whether that flow is going in the right direction or not,
Yeah.
correctly or not. Because many a times one action might trigger another action in an automated way, right? So whether
Yeah.
the different components integrate with each other properly with the right flow or not. So
Yeah.
typically the purpose is that integration testing aims to uncover issues related to the integration of the different parts of the system and verifies that the units work correctly together as a whole instead of working correctly as an individual, right?
Yes.
What is the purpose of UAT, acceptance testing? Simple. It
Business is
verifies whether the application as a whole fulfills the users and the business needs. Means that it has to answer the questions like whether the software do what it is supposed to do or not, right?
Yes.
Next point where the comparison can be done is dependencies. So with respect to unit testing, what are dependencies? Or are they applicable? No. Unit tests are typically isolated from any external dependency or service. How do we achieve this? Because many a times the code that you're writing as an unit might be depending on another unit. Like the business layer might need to interact with the data access layer, where the data access layer may not be present at the time, or it may be in the construction phase. So this is where we do the mocking. We use mocks, stubs, fakes, etc. to simulate the external interactions by assuming that whenever the external dependency is integrated, it will not make any impact on my unit, right?
Yes.
I focus only on my unit. What in case of integration testing? Integration test will involve the real or simulated interactions with external systems. Might be some other service, might be database. Test how the components interact with each other. Means with integration testing, again, if I go back to the data access layer, business layer, I need the business layer to be tested with a real data access layer, or the near to real data access layer, means simulated one, which actually integrates with database and provides me some data. The data may not be the real data coming from the real database, but functionality wise, I want it to be real. Understand? Here I don't use mocks or fakes. Got it?
Yes.
What with respect to the acceptance testing? As we discussed, acceptance tests typically interact with the system as a whole. Means they will be using the real data and almost the production ready environments. So this is where probably we can say we enter the environment called a staging, which is near production environment only, right? Simulated production environment, where the users get the feel of the real release software. Yes or no?
Yes.
Next is automation. Unit tests are highly automated and are usually run by the developers during the development process itself. Whereas integration tests also can be automated, but they will often require more setup, more configuration compared to unit tests. And then coming back to the acceptance test, usually these are manual, but can be automated if required with the help of some specialized tools. But to get the best out of the acceptance testing, usually acceptance tests are often a mix of automated and manual testing, with the actual user scenarios or workflows being tested manually, right? I mean, the inputs will not be automated here. Executions may be automated. So something like what Selenium does. or something like what the user interface based tests do, right?
Yep.
Then the next is benefits. Unit testing benefits are like it helps in catching the code errors, logical bugs pretty early in the development process, encouraging the modular and more maintainable code, and providing the fast feedback to the developers. Correct?
Yes.
With integration testing, the early detection will not be applicable, though it helps detect the issues which arise when different units or components are interacting with each other. Purpose of this would be to ensure that the system as a whole functions correctly. Correct?
Yes.
With respect to acceptance testing, benefits are like to provide a high level view of system functionality and help validate the overall system behavior to make sure that the software meets the customer expectations and the business needs. Right?
Yes.
So ultimately, the different forms of testing complement each other with different purposes being served in the software development process. Only unit testing or only integration testing or only acceptance testing will not produce the desired results at the end. They all need to be there. Correct?
Yes.
Any questions here?
No.
Okay, so logically here we can take a break before we start with the discussion on the N unit, MS test, X unit, etc. Because this will involve a lot of implementation as well. So we will take a break over here. We'll resume at 11 and we will then take it forward with the comparison of different testing frameworks and then the examples being made using X unit. Okay,
Yep. Yep.
so 11 o'clock we will be resuming.
Okay.
Hey guys, I'm back. Shall we proceed?
Yes, yeah.
Yeah. So let's talk about the most popular unit testing frameworks with respect to .NET precisely. Framework or library, it can be anything. First is obviously the Microsoft's very own MS Test, already integrated with Visual Studio and a sort of a complete framework. Then we have a third-party open source uh, library called as NUnit, and another framework built on the top of NUnit by the name XUnit. These are the most popular frameworks and libraries used for unit testing. I hope these names must be known to you. If you have already done some work on unit testing, maybe all, maybe some of them or one of them you might have already worked with, right? NUnit is basically one of the oldest and most widely used unit testing frameworks for any .NET application. It was built by the same team that built JUnit, which was the most popular unit testing framework for Java. NUnit provides a very simple way to create the test methods and their properties with the help of .NET attributes. So usually whenever you are creating a test method, you mark it with the attribute called as test. Automatically your test framework detects this and uses it with test runner to execute the method and collect the results, positive, negative, whatever it is. And uses mainly the color coding red and green. Red means the failed execution, the green color means the passed execution. Whether you run the test runner on command line or you use the NUnit UI to run your test cases. And the class which basically contains these test methods usually gets the attribute as test fixture, which means it's an indication to the test runner that this class contains the series of test methods, where each test method is indicated by the test attribute. It by default supports the parameterized test, which allows you to run the same test method with different input values, where the input values can be picked up from the test cases already predefined by your architect team or the QA team. Maybe in the form of XML, if it is present, you can actually have some automated code also. It by default offers some advanced assertion methods for validating the expected outcomes. When I say assertion means it just does some comparison like run the target method, give the input to it, and see if the desired result and the actual result matches or not. If not, test is declared as failed. If yes, test is declared pass. And as I said, it supports test fixtures, test categories also to group the similar type of tests, and then the test runners for organizing and executing the tests. Okay. A sample I'll put over here. So here is the test fixture class, math tests. Assume there is a class called as math, in which there is a method called as add or add two numbers. Takes in two integer parameters and returns the sum. We have a test fixture which contains a test method, add two numbers, return sum. Here we give some input. This is something what we call as a range. This can be done here programmatically, in which case we have the option of picking the input values from some Excel sheet or something, or else it can have the parameters where we can pass the values. Then act, which is the actual call to math.add with A and B going in as parameter, collecting the result. And then using assertion method called as R equal, we are just comparing what I expect is 5 and what is the actual result, compare it. R equal method we are using means the two things should be same, equal. Then the result will be declared as passed. Got my point? Yes. This is a sample unit test case with n unit. Next is MS test framework. Built-in test framework, as I said, for .NET, and by default used with any application being built using Visual Studio, right? Here, MS test is also built in a way that it uses the attributes only to create your test cases. So the class gets the attribute as test class. Where we had test fixture for n unit. Here we have more intuitive attribute name called as test class. And then the method that basically contains the test code is declared as test method. So it's easy for anyone to understand compared to n unit. This is more natural terminology, right? Features and benefits, if I talk about this MS test framework being Microsoft's own, has tight integration with Visual Studio, which makes it a default choice for most of the .NET developers. It by default supports the data-driven tests, which allows you to use the external data sources for testing, means for input values, even for expected results also. Provides a set of assertion methods for validating test outcomes. Again, asset class is there. And this additionally supports the parallel test execution also, taking advantage of .NET parallelization with TPL, Task Parallel Library. Sample code for this I'll place over here. Similar one. Main difference that you see is just the attributes. Rest of the things we are doing are almost the same. So here, one thing should be very clear that if you learn one of the unit testing framework, how to work with it, you can actually work with any of the unit testing framework pretty easily because they have a lot in common. Understood? XUnit is relatively newer, completely open source unit testing framework for .NET. Inspired by JUnit, NUnit, and in addition to what JUnit and NUnit provides you, it follows a more modern and extensible approach, making it more suitable for modern applications. Here also, again, the attributes are there, where we have attributes like fact for single unit test case, test method. And then there is something called as theory also, where fact is used for simple test methods with no input parameters. Theory is same as fact, but in addition, it allows the test methods to be parameterized. Means the parameters can be passed to the test code. Features and benefits, if we talk about, it is highly extensible and follows more modern and modular architecture. This also supports parallel test execution and allows test discovery as well. So your programming environment can automatically detect where the tests are. Automation becomes more easy here. Emphasizes convention over configuration. So less number of attributes are there because attributes contribute to configuration. Rather, it emphasizes on convention means naming mainly and the standard other conventions for coding, which makes it easy to use with very less boilerplate code. Okay. And then this encourages one test per method approach for clarity. Instead of going with multiple assertions, go for single assertions at one time. The sample code is here. Similar thing, you can see the class doesn't have any attribute on the top of it. Method has got the attribute fact. No input parameters are there, so fact. If I want to parameterize this section, then I'll use theory instead. The work being done is quite similar. Again, we do have assertions only, right? Yes.
Yes.
So practically, each of these unit testing frameworks has its own strength and suitable for different project requirements. Usually, the choice of the framework will often depend on factors like team preparedness or familiarity, tooling available for the testing, and then the specific project needs. Regardless of the framework chosen, unit testing we know is a critical practice in the software development cycle to ensure the code quality, modularity, maintainability, and reusability and reliability. Right? Yes. Any questions till now? So let's see how exactly we take it ahead with the practical implementation. X unit will be our chosen framework because it is more modern, more newer, and more suitable for the modern requirements. Hence, X unit is what we will prefer. So let's say I go for a new project. To keep the thing simple to start with, I'll go for a library project. Let's say this contains my reusable code. Class library with C Sharp, Android, Linux, Mac OS, Windows, and library tags. I'll go with. I'll name this class library as UT for unit testing underscore demo X unit. And I want to put it under demos, new folder, unit testing. Next, .NET 5, create. Let's rename this class1.cs file to, it's arithmetic, or maybe just calci. Click yes, so that your class over here also gets renamed. It has got couple of methods: public int add, int x comma int y, return x plus y. Then I have public int subtract, int x comma int y, returns x minus y. Likewise, you can create other arithmetic methods also. Is it clear?
Yes.
Next, I want some functionality that tests this code. Usually, I keep the test cases into a separate project. So let's right click on solution here in Solution Explorer, add new project. This project also I'll try to create as a class library only. The same template I'm choosing. Next, I name this as my project name dot tests. So UT demo X unit. Dot tests. Usually that's the convention used. Next, .NET 5 framework should be the same as your same or higher version as your actual application that is being tested. Create. Let's rename this class to calci tests. Click yes, so that your class is also renamed. If not, rename it manually. Here, now we need to integrate the X unit framework here. And this project also should be known to this test case project. So right click on dependencies. First of all, say add project reference. Select UT demo X unit. Click OK. So your project dependency is there on this. Then again, right click on dependencies. Select manage NuGet packages. Browse and search for the package by the name X unit. Here it is, X unit. Got it? Latest stable version, I'll go ahead. Click install. Okay. I accept. And so once it is installed, Let's close this window and back to your test cases. Couple of import statements using ut underscore demo x unit, then using x unit. This is our own namespace from the other class library project, and this is the x unit framework. Done. Let's add a method public void add test. Where I say int a is equals to 2, int b is equals to 3, int result equals to, I want that class to be involved here, calc. Here I say calc equals new calc. And then I say int result equals to calc dot add a comma b. And then I put my assertion. Assert dot equal. My expected result is 2 plus 3 should be 5. I put it here. And what the add method is returning goes here. Similarly, I'll create one more test method. I just copy this, paste it here. I say this is subtract test. Instead of add, here I call subtract. 2 minus 3 should be minus 1. So I say minus 1 is the expected value and then the actual result. But to make sure that these methods are run as test methods, I have to mandatorily mark them as fact or theory. Clear?
Yes.
Save and build everything. In, in your Visual Studio, there must be a menu option called as test. Can you see? Under that, there must be an option Test Explorer. Let's select that. Text Explorer window opens up something similar to this, where your test cases are automatically detected. Test methods. I can run a specific test by right click and run, or I can just select the run all option also. Run all test in view. I have run failed test, run not run test, or rerun the past test, or keep on running them until there is a failure. All options I have. So automatically the regression and everything is taken care of. This first arrow is about running all tests, which I want to right now. Here it shows that the test is not run yet. Two tests are there which are not yet run. I say run all tests. It didn't execute. Why not run? Okay. So 9, 10. Okay, there is some issue with the tool itself. Some configuration issue. It looks like could not find test host. That's why it is skipping all the test cases. Is it the same case with you?
Yeah.
Okay, just give me a moment.
Sanket, we need to install Xunit Runner Visual Studio NuGet package.
Yeah, that's what I'm just checking. So the original issue is resolved. The test host is found. Okay. Ideally, with XUnit, it should automatically install this dependency xunit.runner, the test runner basically. If it has been separated out, maybe that's why it's not taking by default. Let's try. No, it's still not doing it. Test host is also there.
Maybe we need to go to the Solution Explorer and make it as can check which project is running. We added
That
two
shouldn't be
blocks.
the requirement also, because it's a class library project. It cannot be executable on its own. And the test runner actually detects the project, which it is, but not able to execute the test cases, the test methods. Uh, this time there is no warning either. All good, but
Maybe
skip.
rebuild both the class library and we can.
No.
At least that debug point should come to that place while we are debugging.
Yeah, so
35%.
if it executes, it will come there.
Yeah.
It is not even hitting it. It's compiling successfully, but not running the test. Just ignoring. What could be wrong?
Sanket, one more package we need to.
Which one?
Microsoft.NET test.stk.
Okay, let me try.
Microsoft.NET test.stk.
Did you try that? Here we have some issue. Yeah. That's something to do with the .NET version, I believe. Because if you notice that the runner package was giving error, it was targeting .NET 4.6, not .NET 5. Let me try again. Install. Okay.
In some of the thread, like, they are saying like delete from percentage temp. Some of the references may be older.
It worked, I guess. Who passed? Okay, so that is correct detection. It was because of the version. So I'll just show you which all packages are required. So basically, the first one that we installed was XUnit, right? Latest stable version. Here also, if we go with 2.4 thing, that should be okay. But 2.5 for XUnit is also working. You can just continue with this. XUnit is 2.5. Nothing needs to be changed. Then we installed Microsoft.test platform.test host, latest stable version again, 17.7.2. No problem with it. Okay. Third one that we installed is xunit.runner.visual studio. The version to be installed should be 2.4.5. 2.5 will work seamlessly with .NET 6 or later versions. Okay. So if it is already installed with incorrect version, you can just come back over here, change the version to 2.4.5 and update. It will automatically downgrade from .NET 5 to .NET 2.4.5. Once it is done, you can directly go to Test Explorer and say run all tests. There is no error being reported over here. And by default, it should show that all the test cases have passed. To simulate the error, what I'll do is in CalC, maybe here I just say return x plus x. This could be logical mistake. This could be um, done without because of the typo error or something, right? Here it said initially one was passing. Here also at your code itself, you get the report whether the test case passed earlier or not. I go back to Test Explorer. I run all the tests once again. This time my initial test should fail. I'll say run past tests. Or should I rebuild? and then say test explorer, run all. One passed, one failed. So if I'm looking for failed test, it shows me here which one has failed. Values differ. Expected is 5, actual is 4. Past test also I can see here. If I want to see all, I can see all together using these buttons, right? I can say run this again or debug this for me so that I can see what's going wrong. It comes here. Then usual debugging techniques like F10, F11 function keys. Here goes the call to add. And there I realize that, okay, there is a typo mistake or there is logical mistake. I just get that corrected here. Let's close this. I go back to Y, save, and then directly run all test also can be selected here. It automatically opens Test Explorer and shows me all are passed now. Got my point? You can also configure the settings like here, if you see run test after build, whenever the build activity is performed, automatically the test cases will run. Let me close this. Let me put X once again for simulating the code change. I just clean the solution and build again. Automatically, it launches the test runner. Automatically, it runs the test cases and lets me know one of the tests is failing. I close this. I change this back to the correct code, save, and rebuild again. It should launch the test runner again and shows me that tests are passing. Yes.
Yes.
Yes. So what is the setting for that, Sriket?
Simply here in settings, you need to select run test after build.
Okay.
And if your methods are quite complicated, taking a lot of time, in that case, you can also activate run test in parallel. So all tests will be run on different threads simultaneously. Understood? Taking advantage of your multi-core processor system. Okay? You can run the specific test from here also. Just click on this and you can say run all, debug all, or run debug. Run all means all test cases. Run means specific test case. Usually this is useful when I have 10 test methods and one or two of them are failing. So I can just say run the specific test case instead of running all. Make sense? This is in case if I'm going with manual execution. If it is automated execution, I need not use this feature at all. Clear? Yes.
Yes.
You cannot test my web APIs also like this. Yes. Web API is also a class library project only. And why class library? You can test the functionality in your executable files, exe files also. You just need to add the reference and then call the respective methods over there. Process is quite same, whether you are working with any type of application. Got my point?
Yes.
Now, what code goes over here is your actual functionality, and what code goes over here is something that needs to be aligned to the test case defined on paper or in Excel sheet or wherever. Your input should be based on the test case. Your expected value should be based on the test case. Correct? Assert has got multiple other methods. So you have equal, you have contains, does not contain, does not match, empty, ends with, starts with, equivalent. You can explicitly cause the test to be failed also by calling fail method. If you are looking for a false value as a result, right? Different assertions you have. You can explore these. If you want that in some sort of input, I expect an exception to be thrown back from the called method. You have assertions for that also. Throws means some exception. Throws, generic one means here I can specify this type of exception I expect, and so on. Can be explored, right? Now, let's talk about the next thing, test-driven development, popularly called as TDD. What exactly it is?
Saket, one more query.
Yeah.
Actually, means I have used MS Test, and
Yeah.
for mocking purpose, we have used the mock framework. So, can we use the same for the XUnit as well?
Yes, without any problem. And that we will be looking at in the next session tomorrow.
Okay, got it.
Okay. So you can use mock, you can use fakes also, Microsoft fakes, and
Oh,
any other third-party open source library, usually available with the help of NuGet packages now. Okay.
oh, yeah.
Fine. So test-driven development. By name, it looks like it might be some development approach to be followed, right? Approach or practice to be followed. So yes, it's a development practice or development approach that is followed by the developers to emphasize writing the test before writing the actual code. First write test, then start developing the code. So you write the test to make your code fail for early detection. So when you write code, initially it might start failing, but then you use refactoring to make it work correctly so that the tests are passed. This is where we use the term called as red-green refactor. Start with all reds, refactor the code to get green results. Keep on doing this until and unless all reds are converted to green. This is the most fundamental part or the backbone of the TDD development practice or TDD development approach. Is that clear?
Yes.
What are the benefits of TDD? First is improved code quality. As TDD encourages you to write more modular, clean, and maintainable code, because you must think about the testability from the beginning. Because tests are written first, the next benefit that comes in is rapid feedback. You keep on getting the rapid feedback. The moment you change the code, the test can be configured to run on its own, and they give you the rapid feedback immediately. So whenever the test fails, you know immediately that something is wrong. So that assists you in debugging the code more efficiently. Yes or no?
Yes.
Then regression testing. Again, if you are choosing the automated execution of the test on build, regression testing will automatically be working for you. Any changes to your code will cause a test runner to execute the test, which will ensure that the changes made into the code are not introducing any new bugs. So before committing the change, you get to know that my change is acceptable one or not. If all tests pass, then only commit. If you are using an automated continuous integration pipeline, in that you can make a rule that accept the checked in code if and only if all tests are giving green results. Then, as we discussed earlier, better documentation, because it allows your code to understand more quickly. And while writing the code itself, we get the better understanding. What is the input? What is the output expected? So you can write the code accordingly. And your next benefit will be design guided by the tests. Means your entire code development will be based on the test. Automatically you get the guidance. How I should write my code, how should I proceed? So less chances of failure or negligible chances of failure, right? Understood? So in our current example itself, if we look at how I should have approached, I should have created the test project first. Here I could have used mocking, right? So that the result would have been always positive. Here, then I would write the Calci class, the actual one. And I'll configure my test cases to run automatically. So once the original Calci class comes in, the mocking framework goes out. And by default, I get the quality code here. Understand? Yes.
But that takes a lot of development time, right?
How? Because test case, anyways, you have to write sometime, right? Why not write it at the beginning? Because see, if you are working with any code which is based on a domain which you are not aware of, probably you will be building that in step-by-step manner only, right? Write something as per your understanding, get it validated by some domain expert. If he points out some issues, you rewrite the code, modify the code. That's the same thing with what we are suggesting with TDD, isn't it? So initially it may look like that it might be more time consuming, but actually it does save time. Instead of writing the whole code and testing at the end and then getting a failure report, it will always be good that fail early. Get the early feedback, modify the code to make it work correctly. So whatever code that comes out at the end will be the already tested code, quality code. Understood? Yes.
Yes, Sanket.
Now let's talk about the best practices for writing the effective unit tests. Unit tests. First one is that says test one thing at a time. Don't go for multiple assertions. This follows the single responsibility principle as well, where we say that each unit test should focus on verifying the behavior of a single well-defined piece of code, which could be function, which could be method. Avoid testing multiple functionalities within the single test case. Write separate test cases for separate functionalities. Understood? For taking advantage of better documentation, the second best practice says use descriptive test names. Means one mistake I have done here. I created a test case by the name add test. Instead of, I can say add two numbers test. Add two numbers test. That would be more descriptive. Got my point? So that it can serve the purpose of better documentation. Got my point or not? Yes or no?
Yes.
Next is keep tests small and focused, which follows keep it simple and stupid principle. Write very concise and targeted tests that are easy to understand. Avoid unnecessary complexity and keep your test focused on specific functionality. Because here you are not writing the code which will be used by the end user. You're writing the code to test your actual code. So keep it as small as possible, as focused as possible. Remember, you are doing unit testing, not the complete application testing, right? UAT or integration. Then always follow the 3 steps we saw in the sample code snippets. That is what we call as arrange, means configure the input. Act means call the functionality. Then assert means check if it meets the expectations. This is something what we call as AAA pattern. But my point? Arrange means set up the test context or inputs. Act means perform the action being tested, means call the actions. Assert means verify the expected outcome. That makes your code more readable. Next is isolate dependencies. This is where we go for mocking. Sometimes we also use the term called as stubbing. So if your dependency is not created, use a mock dependency, so that your test only focus on the code you are testing instead of depending on the underlying code which it will be calling. That will be tested with integration testing. Next is avoid global state and the side effects induced by it. Every test must operate on its own data. The result obtained by one test method should not be used in another test method because it may cause side effects. This will make your test more deterministic without affecting the other tests. Understand? Next is use test data generators and factories. Basically, this is a kind of a suggestion to make use of some tooling that creates the test data automatically instead of giving the hard-coded input. So advantage is that it will simulate the realistic test. In our test case, we provided hard-coded data. Not only input the expected result also. Correct? That should be avoided. Is it clear? Yes?
Yes.
Next is test boundary conditions, means extremes, and which is also called as edge cases. Try giving the biggest, largest possible values. In extremes, what happens? Where usually the bugs and unexpected behavior are found. So check if your code has been written in a way that it takes care of the extremities also in terms of input. Your code should be robust enough. Intention is that. Next is a simple requirement. We already discussed about it. Run all the tests in isolation. Then, as I said, ideally your focus should be on making the test run in automated fashion by integrating it with the CI pipeline, continuous integration pipeline with automation. So that will make sure that none of the code which is not tested goes into your testing. Does that make sense? Yes or no?
Yes.
I want whenever I make the code changes, automatically my test cases must get triggered. Right? Next is test coverage. Your target should be on achieving the highest test coverage. Means make sure that most of the code is being covered under test. But do remember that just having 100% coverage doesn't mean or doesn't guarantee the bug-free code. Focus on the testing of the critical and complex parts of your code as well. So 100% test coverage is something important, but put more focus, more emphasis on the critical and complex parts. Next is another simple requirement which says maintain tests alongside the actual code. So if your code changes because of some change request, accordingly your test cases must also be updated. Because if business requirement has changed, definitely the test case has to be changed as well, right? Next, use assertions wisely. Many a times you will find that some comparisons can be made by more than one type of assertions. Okay. So there you have to find out what is the most suitable assertion and use it. Is it clear? Wherever possible, use parameterized tests. So that you don't need to hard code the values. And you can run the same test with multiple input values in the single go. This reduces your code duplication and also ensures thorough testing. I hope this is also clear. Yes or no?
Yes.
Next is TDD. Consider practicing the TDD, which means you write tests before implementing the code. And as we discussed earlier, the TDD can lead to more testable, maintainable, and more modular code. Yes or no? Yes. Next is refactor tests. So just like your production code, your test also should be refactored to remove any duplication of the code, test code, I mean, improve the readability of the code and maintainability of the code. So this is one of the feature that we pick up from the regular best practices for the coding, right? Next is review and pair programming. So if you yourself are writing your test, consider your colleague or colleagues to review your test. Or wherever possible, ask your colleague to write the test for your code. That is what we call as pair programming. So that the test can be written collaboratively. You write the test for them, they write the test for you. Because usually our own work, finding the issue, the bug into it is little difficult. According to our viewpoint, what the code we write might be the correct one. So there has to be a pair of fresh eyes looking at your code so that something that you anticipated is correct is not actually the correct one. That can be spotted by the colleague easily. And then whether to accept their recommendation or not, that depends on the outcome of the discussion. If there is a conflict, we can involve a third person also, who might be a little bit more senior, who can give you the input in this case, right? Clear? Yes or no?
Yes.
Something like taking the second opinion, right? Then keep the tests execution fast. If your tests are running slow, they can cause hindrance to your development process and workflows. So wherever possible, use the test runners that support parallel execution. XUnit does support, right? MS test does support parallel execution. Instead of running sequentially, all tests might run parallelly, taking advantage of your multi-core processors, which are a very common availability these days. Correct? Clear? Clear?
Yes.
Next is document the intent of your test. Why you are writing the test? What is the purpose? What is the outcome? So for this, include comments into your test code to clarify the purpose and intention of the test. This is very, very important, especially with complex scenarios. Understood? Yes. Next is monitor and analyze test results. This is very important step because if you don't do this, you'll not be able to find issues. Even if you find the issue at a certain point in time, how do you avoid the recurring issue? Same type of mistake if you keep on making in the code. That doesn't look good. If you monitor, if you analyze your tests properly, the test results properly, in the future, you don't make the same mistake. And also you can find out the additional, the areas into your code where the additional testing might be required, right? Got it? By following these best practices, you can create highly effective unit tests that helps you maintain the code quality, improve software reliability, and support agile development practices. Clear? Is that clear?
Yes.
Now, moving on to something called as test fixtures. So in our example, here you do see there is some common requirement. I'm doing it redundantly. Calci object needs to be created every time whenever there is a test that runs. Yes or no? Can I improvise on this? Yes. For this, ideally my original class itself must implement a disposable pattern. So I say calci implements iDisposable interface, which makes sure that if any resources are there, my class contains the code which can dispose those unmanaged resources efficiently. Right? So maybe for now, I just say console.writeLine object disposed because I'm not having a dependency currently on any unused, unmanaged resources. I'm just simulating this. Then I make my test class also implement iDisposable and implement interface, which will cause dispose method to be introduced. The common part all get moved out from here. Calci equals to new calci are removed from both of the methods. Test methods, I mean. What I want is I have a private read-only declaration for calci. And then there is a constructor for the current class. Just say ctor tab. Here I say calci equals to new calci. And what dispose does is simply makes the call to calci dot. So I have this code, which basically looks like setting up the text fixture. This is the disposal of the test fixture. And then the facts or theories implementing the test cases actually. This brings in the consistency, code reusability, better efficiency, and then the organization of the common code. Better organization, I mean. Yes or no?
Yes.
Yes.
There will be no impact on the test runs. So I just say run all tests here from test menu. This should all pass just like earlier. There is no issue. Okay. Yes. So what is the test runner that we are using here? XUnit, correct? We installed a package for that, which was having some version issues. XUnit test runner we are using, without which the test will not run. They will be ignored, correct? Now, one more thing we'll see here. This add, subtract, multiply, divide, all look to be the related test cases, right? So here I can actually say this class actually represents the collection of tests related to calci functionality. This is something what we call as test suites. Related tests go in one implementation. This is again contributing to your documentation. Understand? With this, While running the test cases, I can actually select which collection I want to run. Is it all tests or is it a specific collection? We build it again. Let me clean this first. Collection will appear here and I can specifically set the filter that I want this particular collection only to run. Collection means all test cases into that or test methods into that collection will run. Something like selecting this and saying run. The other test will be ignored. This is more important when you are running the test cases from command line. Is it clear? Because with command line, you don't have the UI like this, where you can right click and select. Yes or no?
Yes.
Yeah, so that is it for what is mocking, what it does, how to set it up, something what we call as the test doubles, which assist in isolating the code under test environment. Okay, different testing strategies, some unit testing for the asynchronous code, how it is done. These are the things that we'll be discussing in tomorrow's session. Clear?
Yes.
Okay, so that is it for today. See you tomorrow. Same time, 9:30 a.m.
Okay. Bye.
Bye-bye till then.
Bye. Thanks.
Thank you, sir.
Thank you.